So binomial distribution is really just a fancy way of talking about the probability of an event occurring. And this is a great example from the curriculum. The binomial distribution, this problem is saying that assuming that a boy and a girl birth are equally likely, right? So it's just as likely to have a boy as it is to have a girl. The variable x represents the number of boys born to a family. So we're going to go ahead and just write this here, that x equals boys, and we're going to put that aside for just a second. If a family has 3 children, we want to look at the probability distribution table for what is the likeliness that none of those children are boys, that one of those children are boys, 2 of the children are boys, or all 3 of the kids are boys. And what we need to do is first figure out what the probability is of having one boy. So we are going to set up our fraction, and the way that our fraction always looks is that the numerator is going to be the number of positive outcomes, and those are really just the outcomes that we want, right? Our desired outcomes. And the denominator is going to be the total number of possible outcomes. So in this particular case, the positive outcome is going to be how many boys. So we're going to have one possible way that you can have a boy, and then there's 2 possible outcomes total because you can have either a boy or a girl. So we have a 1/2. Now once we divide that out, we actually get the probability of 0.5. And a lot of times in class I've been working with the fractions and keeping it in fraction mode. You can do it whichever way you're comfortable with. You can convert it right away to the decimal and use 0.5 throughout the problem, or you can keep it in the fraction mode and use it as 1/2. For this example, since I've been doing it in class with the fraction and keeping it in that fraction mode, I'm going to go ahead and use the decimal today. So we're going to have 1 child, 2 children, and 3 children. Okay. I'm actually going to highlight that in green instead of blue so that you can tell the difference between the green and the purple. Now, if we're going to have 0 boy kids, then the first one here is going to have to be a girl. The second one is also going to have to be a girl, and so is the third one. If we have 1 boy in our situation, though, that boy could either come first, second, or third. So we could have a boy here. This would be a girl. And this would also be a girl. Or that boy could be in our second spot. Could be, and that would have to be a girl here. I'm going to write my boy down there for the next one. So these are 2 of the possible situations where either we have 0 boys, or there's 3 different ways here that we can have 1 boy. Okay. Now looking at 2 boys, we can do the first child could be a boy, and the second child could be a boy, and then the third child would be the girl, And this is going to actually work out very similar to the one up above, because before we had girl, girl, boy, now we're going to have boy, boy, girl. Then the other option is for our boy to come first, a girl to come second, and a boy to come third. So I hope that you can kind of see these patterns as we're going through, oops, that's not green, as we're going through the situation, and just we're really setting up the problem at this point. So then the last option is that we could have a girl first and then two boys. And this possible outcome here would actually give us two boys total. And then last but not least, it would be our all boy situation, where we have boy first, boy second, and boy third. And that would give us 3 total boys in our family. Okay, so the way that we're going to look at these is we're going to set up each one of these as a probability distribution, but we're going to replace, instead of girl, we're going to look at the probability distribution of us having a girl in this situation. So in this case, when we have a girl, and we want to have a girl, which is what we're going to have right here, we're going to use the probability of having a girl, which is 0.5. Now, it's 0.5 really for all of it, right? Every single one of these here is going to have a probability distribution of the 0.5, because that's the desired outcome for this particular situation, right? You're either having one or you're having the other. So when you multiply, or when you get each of these set up, we're actually going to multiply them together. And that multiplication is the function that we do to just say, okay, so we've got, you know, a 50% chance here, 50% chance there, and a 50% chance on that third one. But when you combine all 3 of those events happening, what is the likelihood that all 3 of them happen? So we're going to use multiplication to figure out the likeliness of all 3 of those happening. And so when we multiply, it's going to be 0.125. So that's 12.5%. And that's the likeliness of us being able to have 3 girls. Now, if you notice, this probability down here at the bottom, the likeliness of us having 3 boys is going to be exactly the same. So we're going to have, and I'm going to write it below the box so that I have just a little extra room. All right, and the reason why it's the same is because we're going to have 0.5 or 1/2, right? If you're going to use the fractions, it's a 0.5 chance of having a boy, 0.5 chance of having a boy, and surprise, 0.5 chance of having yet another boy. And then what we're going to do is we're just going to go ahead and multiply those probabilities together, and that's going to give us the same 0.125. So now we need to look at these ones in the middle. And these probabilities in this middle section here, we're going to go ahead and look at the probability of us having 1 boy out of the 3 kids. And that probability is going to be just a little bit different. And the reason why is because when we look at that situation, there's 3 different ways that we can have 1 boy and 2 girls. So we're still going to have a 0.5% chance of having a boy, a girl, and another 0.5. And again, if we were using fractions, these would be 1/2. And then the third child, you still have a 0.5% chance. So this problem gets just a little bit confusing because if you think about it, we're doing all 0.5% chance, right? There's an equal chance of either one. It's like flipping a coin. So we're going to go ahead and multiply these together, and no surprise, we're going to get 0.125. And if we were to do the calculation for the next step down, we would also get 0.125. And if we did it for the third one, we're also going to get 0.125. So now we need to think about what's going on, right? The ways that we can have just one kid, there's three possible ways. So we're going to take those three probabilities, one for each way, and we're going to take the sum of those probabilities. So we're going to add them together so that we can get the total probability of having one boy out of the three kids. So when we add those all together, we end up getting 0.375. And I'm going to write this just below the box again here, just for the sake of space. So 0.375. And then if you notice, we have the same three opportunities here to have two boys. And so we're going to add those all together again and get the same 0.375. All right, I hope that helps.